Caterpillar Acert engine that destroyed its own reputation. If your dad drove a truck in the 90s, he probably swore by Caterpillar, not because someone told him to, because the engine earned it. The 3406E was one of the most trusted diesel engines ever bolted into a Class 8 truck. And then Caterpillar did something that cost them everything. They tried to fix a problem that wasn't theirs, with technology that wasn't ready, and lost a market they'd spent 40 years building. So, let's start at the beginning. Not the beginning of the problem, the beginning of the legend. Caterpillar's name was built on dirt, literally. The company was born in 1925 from a merger of two tractor companies, and for decades, they were the kings of construction and mining equipment. That bright yellow iron became a symbol of heavy industry around the world. But somewhere along the way, Cat decided they wanted to conquer the highway too. Their first truck engine, the D468, showed up in 1939, a six-cylinder making about 90 horsepower, not exactly earth-shattering. World War II hit, and Cat shifted focus to the war effort. They didn't get serious about trucking again until the 1960s when they rolled out the dual overhead cam, 1693. Truckers claimed that engine could push past 425 horses. Whether that was true or wishful thinking depends on who you ask. But the real magic started in 1973 with the introduction of the 3406 series. 14.6 liters of inline-six diesel, and the beginning of something special. The 3406A was a mechanical engine, simple, brutal, reliable. It made between 310 and 425 horsepower, and it would run and run and run. The engine evolved through the B model in the late 80s, the C model in the early 90s, and then in 1993, Cat did something that changed the game, the 3406E, Caterpillar's first fully electronic heavy-duty diesel, and it was magnificent. Between 375 and 550 horsepower, depending on the configuration. 14.6 liters of displacement, electronic unit injection that gave it precision no mechanical engine could match. The 3406E was going into Peterbilt's, Kenworth's, Freightliners, and Internationals. It was the engine of choice for premium long-haul tractors across North America. And here's the part that really mattered to the guys who drove them. The 3406E would go over 1 million miles before needing a major overhaul. 1 million miles. Some operators reported 1.2, 1.5 million miles. In the trucking world, that's not just good. That's a mechanical miracle. By the late 90s, Cat was running fuel efficiency contests, giving away prize money to the most economical truckers running their engines. Their 3406 and 3408 engines were hitting 7 miles per gallon, when most competitors were struggling to reach 5. The brand loyalty wasn't marketing. It was earned at truck stops, where owner-operators would stand around debating which engine to buy, and not too many people argued when you said Caterpillar. In December of 1999, Cat shipped the last two 3406E engines from the factory. They were the final units in a line that had produced nearly 575,000 engines worldwide. The 3406 was done, but the C15 was ready. Same DNA, same basic architecture, 15.2 liters of displacement, and it carried the legacy forward. By 2006, Caterpillar held almost 30% of the Class 8 heavy-duty engine market. They registered over 81,000 new engines that year alone. Cummins, their biggest rival, was sitting at about 25%. Cat was the undisputed king. Then the government showed up, and everything started to fall apart. Now, to be fair, the EPA didn't come out of nowhere. Emissions regulations had been tightening since the early 90s, and everyone in the industry knew stricter rules were coming. The problem was how to meet them. And to understand what happened next, you have to go back to 1998. In October of that year, the Department of Justice and the EPA dropped a bomb on the entire diesel engine industry. 7 major manufacturers, including Caterpillar, Cummins, Detroit Diesel, Mack Trucks, Navistar, Renault, and Volvo were accused of using computerized defeat devices. These were software tricks that let their engines pass lab emissions tests while pumping out illegal levels of nitrogen oxides during normal highway driving. The total penalty was $83.4 million, the largest civil penalty in environmental enforcement history at the time. Collectively, the companies would spend more than $1 billion to settle the case. The affected engines had been pumping out excess pollution equivalent to adding 65 million extra cars to the road. So yeah, the EPA was not in a forgiving mood. As part of the consent decree, every manufacturer had to meet the 2004 emission standards by October of 2002, 15 months ahead of schedule. That was the punishment: get clean or get out. Now every other major engine maker looked at this deadline and reached the same conclusion: exhaust gas recirculation, EGR. The concept was simple enough. Take some of the exhaust gas, cool it down, and send it back through the combustion chamber. The second pass burns off additional pollutants, reducing nitrogen oxide output. Cummins went with it. Detroit Diesel went with it. Mack went with it. Everybody went with EGR. Everybody except Caterpillar. Cat looked at EGR and said, no. They didn't just decline quietly. They actively campaigned against it. Cat's CEO, Glenn Barton, publicly argued that EGR was flawed. The company pointed to reports that EGR engines could require 2 to 4 more repairs in the first 500,000 miles compared to pre-regulation engines. They warned that engine life to overhaul could drop by 25%. And here's the thing Caterpillar loved to point out: EGR systems needed to shut off during high-stress driving conditions, which meant, as Barton put it, the EPA was promoting a solution that employed exactly what they had just punished the industry for. So Cat went its own way. In March of 2001, they abandoned EGR development entirely and bet the entire on-highway engine business on something new, something they called Acert, Advanced Combustion Emissions Reduction Technology. It was the largest and most expensive development program in Caterpillar's 75-year history. The investment topped $500 million, more than 250 patents, more money, they said, than they spent developing the high-drive tractors. The idea behind Acert was elegant in theory. Instead of cleaning up the exhaust after combustion, control the combustion itself. Manage the air and fuel so precisely that fewer pollutants are produced in the first place. The system used next-generation electronic fuel injection that could fire multiple precisely timed shots of fuel during each compression stroke. It used variable intake valve actuation, which let the onboard computer work with the camshaft to control exactly how much air entered each cylinder. It used series turbocharging on the heavy-duty engines, with dual turbos cooling the intake air. And on the back end, a diesel oxidation catalyst handled whatever particulate matter made it through. No exhaust recirculation, no breathing your own fumes, clean air in, cleaner air out. That was the pitch. Cat got EPA certification for the first Acert engine, the C9, in January of 2003. By the fourth quarter of that year, every Cat on-highway engine would carry Acert technology. The C7 was the first to hit the market. Then the C11, C13, and the mighty C15 followed. If you're enjoying this, hit subscribe. We cover stuff like this every week. Okay, back to it. So here's how Acert actually worked, and why it was technically clever, but practically a nightmare. The heart of the system was the ADEM electronic controller. Think of it as the brain that coordinated everything. It managed fuel delivery, air supply, and all the engine functions simultaneously, making thousands of calculations per second to optimize combustion in real time. On the fuel side, the heavy-duty engines used what Cat called MEUI, mechanically actuated electronically controlled unit injectors. These were driven by the camshaft for mechanical force, but controlled electronically for timing and duration. This allowed the system to inject varying amounts of fuel several times during each compression stroke. Not just one big squirt of diesel, multiple precisely timed micro-injections. each one calculated to extract maximum energy while producing minimum pollution. The injection pressures reached 25,000 pounds per square inch. For reference, a standard garden hose runs at about 40 psi. We're talking about pressures 600 times higher than that, focused through injector tips smaller than a pencil point. The variable intake valve actuation was arguably the boldest innovation. CAT adapted a solenoid from their HEUI injector system to work with the camshaft, giving the computer direct control over when and how the intake valves opened and closed. This let the engine adjust its breathing on the fly, more air when it needed more air, less when it needed to control combustion temperatures. The onboard computer adjusted the amounts and timing of air and fuel delivered to each cylinder individually. Every cylinder got exactly what it needed when it needed it. The twin-turbo setup on the C-15 used series turbocharging, a smaller high-pressure turbo spooled up fast for low-end response, feeding into a larger low-pressure turbo that handled the high-volume airflow at full power. The intake air was cooled between stages, which is important because cooler air is denser, which means more oxygen per cubic foot, which means more complete combustion. On paper, this was brilliant. You're attacking emissions at the source. No recirculated exhaust to contaminate the intake system. No extra heat cycling through the engine. Caterpillar's own engineers said fuel economy would equal or beat pre-regulation engines, and they expected the diesel oxidation catalyst on the exhaust side to last as long as the engine itself. No moving parts, no service required. The problem was what happened when theory met the real world. Acert added enormous mechanical complexity. The variable valve actuator system introduced failure points that simply didn't exist in pre-Acert engines. The IVA actuators and solenoids failed regularly. That was essentially CAT's in-cylinder version of EGR, and the components couldn't handle the sustained stress of commercial trucking. The twin turbocharger systems developed issues. The electronically controlled turbo wastegates failed. Turbo seals went bad. Oil leaks became chronic. But those were the early problems. The real catastrophe came with the 2007 EPA standards. For 2007 compliance, CAT had to go further. They added the Caterpillar Regeneration System, or CRS. This included a diesel particulate filter, an after-treatment regeneration device, and an electronic control module. The DPF trapped soot from the exhaust. Periodically, the regeneration system would heat up to burn off that trapped soot. Sounds straightforward. It wasn't. The regeneration system would fail to regenerate. The DPF would clog. When it clogged, the engine would lose horsepower. Then it would shut down entirely. Not limp home mode. Shut down. A 40-ton truck full of freight sitting on the side of the highway. Dead. And the worst part? You couldn't fix it yourself. The trucks could only be repaired at Caterpillar-authorized repair shops using proprietary tools and software. So when your engine died in the middle of nowhere, you weren't calling a mechanic, you were calling a tow truck. To drag an 80,000-pound rig to the nearest dealer, that tow bill alone could run into the thousands. And this wasn't happening once. Fleet owners reported repeated failures. Fix it, get it back, watch it die again. One fleet owner described it plainly. The question wasn't if the breakdown would happen, it was when. Every time the truck went out, you held your breath. The C7 had additional problems specific to the Acert package. Overheating on inclines was common. The engines ran hotter by design to burn off more particulate matter, but the cooling fan didn't kick in until 235 degrees Fahrenheit, while drivers reported overheating at 200 degrees. The instruction to drivers was to downshift to 1100 RPM when climbing hills, which is fine advice unless you're hauling a full load up a mountain grade, and physics doesn't care about your calibration settings. The C7's B50 life rating, the point at which half the engines need a major overhaul, was 450,000 to 500,000 miles. Sounds decent until you remember that the pre-Acert engines were regularly hitting over 1 million miles. The engine's lifespan had effectively been cut in half. Now, here's where it goes from an engineering problem to a corporate disaster. Fleet owners started suing, first in Texas, where 90 Cat-powered trucks from 3 fleets were involved. Then the lawsuit spread. Florida, California, Georgia, Pennsylvania, Louisiana, New Jersey, Minnesota. Eventually, nearly 10 class action lawsuits were filed against Caterpillar, all alleging the same thing. The 2007 through 2010 model year Acert C13 and C15 engines were defective. The Caterpillar regeneration system was defective, and Cat knew it. The lawsuits didn't just allege bad engineering, they alleged concealment. Plaintiffs claimed Caterpillar had been aware of the problems and kept producing the engines anyway. They accused Cat of breach of warranties, fraudulent concealment, violations of Deceptive Trade Practices Acts, and consumer fraud. 22 trucking firms in 18 states signed on as named plaintiffs in one consolidated action alone. One attorney representing the plaintiffs said it plainly. Same case, same issue, same problem. Cat would try to claim each situation was different or that owners hadn't properly maintained their trucks, but it was all the identical defect. Cat stopped sending representatives to the Technology and Maintenance Council meetings of the American Trucking Associations, the one place where fleet managers could confront them directly about the problems, and Cat just stopped showing up. That didn't help the relationship. And then the market numbers told the real story. In 2006, Caterpillar had registered 81,335 new Class 8 engines, nearly 30% market share, the top spot. By 2007, even with the overall truck market declining, Cat fell to 43,907 engines, 25.7%. Cummins, meanwhile, climbed to 52,800, 30.9%. In 1 year, Cummins took the crown that Cat had held for the entire decade. In June of 2008, Caterpillar made the announcement that shocked the industry. They would not produce EPA 2010 compliant engines. They were getting out of the Class 8 on-highway market. Done. The 2008 annual report buried it in a footnote on a graph. One sentence. In 2008, we decided to exit the on-highway engine business, and that was it. A legacy that began in 1939, that had produced hundreds of thousands of engines, that had commanded 40% of the market at its peak, ended with a footnote. Caterpillar said on-highway engines represented just 8% of their total production. The math didn't justify the continued investment. They would focus on off-highway applications, construction, mining, marine, industrial power, the markets where Cat was still dominant and emissions regulations were less aggressive. In 2016, Caterpillar settled the consolidated class action lawsuit for $60 million. Owners who had experienced no CRS-related repairs could receive $500 per engine, 1 to 5 repairs, $5,000, 6 or more repairs, $10,000. Some owners could claim up to $15,000 in documented losses. Over 2,000 claimants were approved, covering more than 11,000 Acert engines, roughly a third of the 35,000 engines potentially covered. Caterpillar denied the allegations to the end. They said their engines were well designed and that they had honored warranty commitments, but they also said that continuing to litigate would be risky and costly for both sides. $60 million. For a company that posted $30 billion in annual revenue, it was a rounding error. But the reputational damage, that was permanent. Here's the thing about trust in trucking. An owner-operator's engine is their livelihood. A breakdown doesn't just mean a repair bill, it means missed deliveries, penalties from shippers, lost contracts, insurance complications. And when you're making payments on a truck that cost over $150,000 and the engine keeps dying, the math gets real personal, real fast. The pre-Acert Cat engines are still revered. The 3406E in particular has become almost mythical in the diesel community. People call it the last of the best. The final engine before emissions controls changed everything. Today, a clean pre-Acert 3406E or C-15 command serious money in the used market. Owner-operators seek them out specifically. They'll repower older trucks with these engines rather than run newer emissions-equipped models. The irony is that Caterpillar's instinct about EGR wasn't entirely wrong. Every manufacturer struggled with early emissions technology. Cummins had problems. Detroit Diesel had problems. The entire industry went through a rough transition, but the other companies stuck it out. They iterated. They improved. They're still in the game. Cat's gamble on Acert wasn't crazy. The underlying engineering concept was sound. Controlling emissions at the point of combustion, rather than cleaning up afterward, is arguably the more elegant approach. The problem was that the technology needed more time, more testing, more real-world validation. But the EPA deadline didn't care about elegance. And once the 2007 standards added the diesel particulate filter and regeneration system on top of everything else, the whole package became too complex, too fragile, and too unreliable for commercial service. Caterpillar still makes engines. Great ones, in fact. Their off-highway products power construction equipment, mining trucks, marine vessels, and generators all over the world. The Acert technology actually matured and improved in those applications, where duty cycles are different, and the operating conditions are more controlled. The off-highway emissions regulations caught up eventually, but Cat had bought themselves time and learned from the on-highway disaster. But they never came back to the highway. And the truckers who remember the golden era of Cat engines, the guys who ran 3406, eased into the ground and rebuilt them and ran them again, they'll tell you the same thing. Cat built some of the finest diesel engines that ever turned a crankshaft. And then they built the ones that ended it all. The factories that made those highway engines are repurposed now. The engineers who designed Acert have mostly moved on, but every now and then you'll see an old Peterbilt 379 rolling down the interstate with that unmistakable Cat rumble, and you'll know. That's a pre-Acert engine in there, still running, still earning, still doing what Caterpillar always said their engines would do. It just turned out that the thing which destroyed Cat's reputation on the highway wasn't a competitor. It wasn't the government, not really. It was the gap between what they promised and what they delivered. $500 million in development, 250 patents, the most expensive program in company history. And in the end, the engine that was supposed to prove everyone wrong proved Cat wrong instead. And there you have it, the Caterpillar Acert. The engine that bet against the industry lost and took a 60-year trucking legacy with it. If you've got a story about running one of these, good or bad, I want to hear it in the comments. And if you're still here, go ahead and subscribe. We do this every week.